Okay, so we have Chandrayaan, Chandrayaan 3. Chandra means moon, Yaan means vehicle. Right?
Yes.
So Chandrayaan, a vehicle that's going to the moon. Right? That's what we are going to learn about. So as you can see here, Chandrayaan is a vehicle that is going to the moon, on the surface of the moon. That is the project. So, the vehicle is made on the earth. The scientists have made the vehicle on the earth. And we have to lift it up to the moon. We have to send it to the moon. How do we send something from the earth to the moon? We need something to carry this, right?
Yes.
Like if we want to carry something, we need to use our energy to move that thing from one place to another. The earth is pulling things downwards, but we have to push it. We have to lift it off all the way to the moon, which is lakhs and lakhs of kilometers away. So, this is the Chandrayaan here. This is not the Chandrayaan, but this is the Chandrayaan. And this Chandrayaan is inside this part of the whole GSLV Mk3 rocket. You cannot see it from outside, but this Chandrayaan is inside. Why do we send something to the moon? That's the first question.
To research.
To do research about the space, about the moon. Right?
Yes.
If we want to understand the evolution of the earth, we can study about the nature and various different things present on the moon, and that might give us some idea of how we came into existence. And the other thing is, nowadays, lots and lots of people and many countries, they want to travel in the space. Maybe there is something important that can help human mankind. And it can make you profitable. It can give you lots and lots of money. How about exploring it? Right? Because we have explored the earth. And we are using the resources of the earth. How about finding some resource elsewhere on this, in the space? That is another objective. And the other objective is, for example, if you want to go far away in the space, far away in the space, we can make it a station. A station, like when we go from Nepal to America, we might need a station, like, for example, transit. Where is our transit generally? Dubai or Singapore. Similarly, in space travel, moon can become our station, a transition, or a place where we have a transit, right? We can have a transit. So let's go, right? Dive into Chandrayaan 3. What's the weight of Chandrayaan? 642,000 kilos. That is about the weight of 150 elephants. And then it has the capacity to lift 4,000 kilos into the space. It can take how many kilos? 4,000 kilos. The whole setup is how many kilos? 642,000 kilos. And it can take 4,000 kilos to the space. And the good thing, or very interesting thing, is that there is an unsaid space competition between countries. Okay? Many countries, they are working together to make sure that also they explore space faster than the other countries, so that they can use the resources, they can use that space. So India is going to be, if they are going to be successful, it's going to be the 4th country in the world to land a mission on the moon, on the surface of the moon. After US, Russia and China. So on the 14th of July, they launched this space mission at 2:35 p.m. from South India, the space center called as Satish Dhawan, on the 14th of July. And now the destination, it's on the way. And where is it going? To the moon. That's the destination here. So let's learn about the different parts now of the mission, of Chandrayaan-3 mission. Okay. So Chandrayaan-3 mission, its maximum thrust, that means in 1 second, it can travel 10.242 kilometers in 1 second. It can achieve that much of speed. Budget, they spent 615 crores of rupees for this project. Distance to cover. What distance should the Chandrayaan cover? 3.84 lakh kilometers. And it is carrying more than 27,000 cryogenic fuel. It's a fuel that is used to power this big beast. It's a beast, right? It's a huge thing. And in 1 second, it can use up to 37.5 kilos of fuel. In 1 second, it's eating up. It's burning that fuel. And the most important day is going to be on the 23rd of August. That's when it's going to be decided whether Chandrayaan-3 mission has been successful or not. It's 42 days long journey. It started on the 14th of July, and we have to wait another 30 days approximately to see whether it's going to be successful or not. Now, Chandrayaan-3. Let's talk about this Chandrayaan, which will be shot, which will be blasted off to the moon. So it has, the name is Chandrayaan-3. What's the name?
Chandrayaan-3.
Where is it flying? Moon. Where was it launched from? Satish Dhawan Space Center, Sriharikota, Andhra Pradesh. And the vehicle that they are using, okay, the carrier that they are using to carry this thing to the moon is GSLV Mk3. Okay? And what is present here in this Chandrayaan? It has 3 major parts, major things. It is taking a propulsion module. This is the propulsion module, this part. A lander, this upper part is the lander, which is going to land. You can see the legs, right? Yes. And then you have a rover, a small automatic kind of a truck, a car kind of thing, which is called as rover, which will travel, which will move in the space, on the surface of the moon. So it has 3 things. And mission, how long is it going to work on the moon? It's going to work for 1 lunar day on the moon, just for 1 day. That is about 14 Earth days. 1 lunar day equals to
14
Earth days. Okay? So only this thing is going to the moon, not the whole rocket. Alright? The rocket is not going to be there in the moon. Only this part. Only this part. What about the rest? What happens to the rest? Now, before we move on to the rest, we have to understand each and every part. Okay, so the various different parts of the whole mission are, you have the upper part called as the PLF, payload fairing, this part, payload fairing, this part here, and you have Chandrayaan-3 inside this, which keeps Chandrayaan safe while traveling, because that's the most sensitive part. It's like our brain. Okay? And then you have different stages, 3 stages. The first one here is the cryogenic stage, or some may say 3rd stage. But this is the cryogenic stage. What is this? Cryogenic stage. The second here, this is S200 solid rocket boosters. These ones, these on the side. These are the rocket boosters. They boost. Alright? They propel rocket forward. And the third one, L110 liquid stage. These are various different stages and various different parts of the Chandrayaan mission. So payload fairing is the nose cone. Okay, before moving on to that, the first thing that when the rocket gets launched, the first thing when the rocket was launched, what happened? These boosters, they are set into fire. They are ignited. So the first stage, we call it the first stage, okay? Cryogenic stage is the third stage. The first stage consists of S200 solid motors. There are motors. And they are called as large solid boosters as well. And inside them, there is hydroxyl terminated polybutadiene. Alright, this is a propellant, this is a fuel that's there present, it's solid. Alright, propellant in 3 segments with casings out of M250 managing steel. And when they are ignited, it creates lots and lots of thrust. So you can see 203 tons of solid propellant. It's about 20 meter long, 3.2 meter diameter. The diameter is 3.2, and it burns only for 137 seconds. As soon as there is fire on these boosters, it burns only for how long? 137 seconds. That's very short. And this is the part which wins against the gravity. They are powerful. This is the one that wins over the gravity. The gravity is pulling the whole 600 tons, right, downwards. So to push that, these boosters play a very, very important role. Alright? So you can see, this was experimented with S200. You can see when it burns, the principle of working of a rocket or S200 is Newton's third law. Every action has equal but opposite reaction. There is an action downwards, right? When the gas is pushed downwards, what happens? The rocket gets pushed upward and it flies off. Newton's third law is always there. Now, the other part is the payload fairing, which is at the top. Alright, which is at the top. This part. Sorry, here. This is payload fairing, okay? So, the payload fairing is the next, is the nose cone used to protect spacecraft. It is there to protect the spacecraft. What is there inside? That's the Chandrayaan. That's the heart of the project. This heart should be protected because the Earth has atmosphere. It can create a lot of trouble when it's moving too fast. When things are moving too fast, it can create friction and it can burn, right? So therefore, we don't want to spoil the whole thing. So that provides the safety. The object to be carried by the aircraft or launch vehicle. Okay, it protects against the dynamic pressure and aerodynamic heating. And this one opens itself at about at the distance of 115 kilometers, about 217 seconds after the launch of the vehicle, after the launch of the rocket. Alright, 217 seconds after that, it opens itself. After it almost crosses the atmosphere, because after the atmosphere gets over, there is no atmosphere outside, so the heating does not happen, right? So, because we have to decrease the weight. As much as we go, we need to decrease the weight, right? Because we cannot carry all the fuel all the way there. Otherwise, it's going to be a problem. Now the next stage. So now we have covered this part. Right? Cryogenic stage. Now this part, the central part. We have finished. Okay, we have not finished this one. We have finished this part, now this part. This is the core stage, L10. This is called as L10. So it is the second stage, designated L110. It is liquid fueled stage. It is about 21 meters height. It has 21 meters height, okay, 4 meters width, and contains 110 metric tons of this chemical substance called UDMH and nitrogen tetroxide. The reaction between UDMH and nitrogen tetroxide creates lots and lots of energy, and is ignited at about 113 seconds to the flight. When the flight happens, after about how many seconds?
100.
113 seconds. Before 113 seconds, what's burning in the rocket? The boosters.
Boosters.
After the boosters are almost over, this gets burned. Okay? And about 965th second, this separates from the whole rocket, the whole vehicle. Alright? We'll get into that later. Now the third stage is the cryogenic stage. The cryogenic stage. Cryogenic means something that deals with very low temperature. So rocket's main fuel also is, one of the main fuels is cryogenic fuel. Cryogenic fuel here used is liquid hydrogen and liquid oxygen. They are cooled at minus 253 degrees centigrade. That means they are like liquid. You can pour them. Pour it. And liquid oxygen is minus 183 degrees centigrade. They are cooled to that level. And they are pushed to a chamber where it is burned. Helium gas is non-reactive gas. So it pushes these two liquids from two chambers, right? Pushes into where? The combustion chamber. Once in the combustion chamber, reaction happens. What is our favorite reaction? H2 plus O2 gives water and energy. This energy is extreme energy. And when it burns, it pushes the vehicle upwards. You see? 28 tons, that is 28,000 kilos of liquid hydrogen and oxygen is present. And this fuel is called as cryogenic fuel because it is at very, very low temperature. If you carry gas, you cannot store lots and lots of gas in a small chamber because we need to make a rocket as small as possible, right? Otherwise, it requires lots and lots of super simple equation. Now, this is Chandrayaan. This is what is to be carried by the rocket, Mk3, right? Now, you have these three parts. The propulsion module. This is what is going to propel Chandrayaan once all the other parts of the rocket are separated. Because most of the parts of the rocket get separated at a very early stage. At about 15 minutes, there is nothing. Only this part is there after 15 minutes. You understood what I mean?
Yes.
The whole rocket that you have seen, this huge thing, after crossing a certain height from the earth, the whole thing gets separated. Only this thing remains. And it is only the propulsion module that remains there, plus the whole thing that needs to be carried. And this is what is going to take things to the destination. Alright? So you have lander module plus rover. Where is rover? Rover is inside, right? Yes. Rover is inside. And this is intermodule adapter. That means it connects these two. And this is the propulsion module. So with every burn of propulsion module, the module will keep spiraling outwards. So it keeps on moving. The movement of lander and module is because of the propulsion module. Alright? It takes things forward. Now lander. If you see the lander is called as Pragyan. What's going to land on the moon? The lander is the part that's going to be landed on the moon. And the name is given Pragyan. Okay? And it has various different parts for various different functions because we are sending it for a specific purpose, right? To get information, data, and learn about the moon. So there is Chandra's surface thermophysical experiment, CHAST, which is used to measure the surface thermal properties, the various thermal properties. What the hell? So the next part of Chandrayaan 3 discussion is going to be to learn how Chandrayaan is flying. Right now Chandrayaan is flying. So time to fly. How? We cannot just shoot off the rocket anywhere, anytime, in whatever direction that we feel like, right? It has to follow certain physical laws of the physics. And therefore, by using laws of the physics, we have to accordingly decide from where to fire, when to fire, what path it's going to follow. We have to know all of these things. And then only finally it's going to land where we want. Can you imagine in this whole huge universe, this whole, the distance between the earth and the moon is how much? More than 3 lakh. 3 lakhs. Scientists, the scientists have been able to precisely land where they want on the moon without going there. I cannot even put my pen where I want right here. I either put here or there, right? I cannot locate. But imagine making a machine that will land exactly where you want. That's fascinating. Fascinating, right? Science is fascinating in that sense. By being here, you can do things there. And you can make machines that can do these things. So, you see, this is how, so this is Chandrayaan. So now, we know various different parts of the Chandrayaan mission, the rocket, right? You have the boosters here. You have this, the main, what was the, just let's, a different stage, the core stage, right? And then you have this cryogenic stage, and this one, you have the payload covering, right? PLF. Now, what happens is, at first, it begins by the ignition of S-200, the booster. The booster ignites, right? Flight time 00. When the S-200 ignites, the ignition of S-200 creates thrust upward. So it starts to move upward. Right? It starts to move upward. And then what happens is, when it reaches the altitude of 62 kilometers, 62 kilometers, about after 127 seconds, these S-200, they separate from the main rocket, the core stage. Now, what happens? The core stage starts to burn now, ignite. The ignition of core stage starts burning, L110 burning phase starts to burn. While it's moving, the PLF, the covering of the nose of the rocket, it starts to open because it crosses the atmospheric level. So now, as soon as the atmospheric level is crossed, you can remove that because it's now safe, more or less, right? So because of that reason, you get rid of PLF. PLF, I have discussed about PLF. Payload fairing, PLF. It separates, right? And then after that separation, what happens? What happens is the L110 burns, right? It's of course burning, and now slowly it's time for L110 to separate also from the main core, the main part of the whole mission. Alright? And then, now, what happens? After L10, this part burns, what remains is this part only, without the payload fairing, okay? The payload fairing, the covering is called as the payload fairing, PLF. Payload is the Chandrayaan itself, okay? The main part of the whole mission, Chandrayaan, is called as the payload. Whatever you are carrying from one place to another is called as payload. We are not interested in carrying this part or that part or that part or that part. We are just interested in carrying payload, Chandrayaan. These things we need because it takes it there. So that's the reason, isn't it? Yeah. So now, C25, the cryogenic stage starts to burn now. The cryogenic stage starts to burn, And after a while, after about burning for about 10 minutes, the satellite, the Chandrayaan separates from the cryogenic part itself. And what remains is only this, you see, this part, the satellite. The satellite or the Chandrayaan. Only that part is now there. Right now, as we are talking now, the only part that is revolving around the Earth is this part. Everything has left off. It's revolving around the Earth. It will revolve for about another few days, and then it will start traveling towards the moon at the right time. The right time will be decided, or it's decided, right? And here you can see the initial speed 1227 km per hour when S200 burns. And then it reaches 48 kilometers in about 110 seconds. And at about, after some time, L110 ignition occurs, right? Reaches about 6,437 km per hour. That's the speed it reaches. And after that also, when S200 separates, the speed increases to 7,000 km per hour. 7,000 km per hour. And then the cryogenic stage starts to burn and the velocity reaches up to 36,000 km per hour. Now the point is, we know that the thickness of the atmosphere is about 60 miles. How much is 60 miles? 60 times 1.6. 6, 36, about 100 kilometers from the surface of the Earth. Once you cross 100 kilometers, you don't have to worry too much about the atmosphere. Okay? Because there is no friction there. Friction of the atmosphere, right? So therefore, now it's all free in some sense. Now let's look at the path that it follows. The path of the satellite. Alright? So, let's have a look at it very closely. So, you start from the surface of the Earth. You start from the surface of the Earth. This is the path that it follows, okay? Very important. And once the booster ignites, the rocket shoots itself up, right? And it comes to the first orbit, this elliptical orbit. It crosses the atmosphere. The Earth is holding things down, right? It's pulling things down. And you have to make things move at least at the speed of 11.2 kilometers per hour. At least with what?
11.2
km per hour. Per second, sorry, not per second. 11.2 kilometers per hour, even I can run. If you want to make things escape from the surface of the Earth, if you want to escape the gravitational pull, you have to make things shoot up at least at what speed? 11.2 kilometers. This is called the escape velocity. This is called the escape velocity. If you can throw things at this speed, it will move out of the Earth. Alright? So, with that escape velocity, what happens is, because it's not going straight upward, it moves with certain angle. You may not need this speed, okay? It can happen with lower speed as well. But, anyways, what happens is it reaches us an orbit called as geostationary transfer orbit, which is 170 by 37,000 kilometers. This orbit. That is to say, the nearest point of the orbit here, the nearest point, you see here, the nearest point here will be 170 kilometers, and the farthest point here will be how much? 37,000 kilometers. So, after reaching this orbit, there is nothing, right? What happens? When it reaches almost to that orbit, there is only Chandrayaan. There is no rocket with it. There is no rocket. I'm not showing rockets here. Why? Because all the different parts have left already. They have been separated. Okay? The rocket has launched Chandrayaan on the orbit. So the rocket, they don't travel to the moon. What happens? It puts Chandrayaan into an orbit. So that orbit is called as geostationary transfer orbit because it keeps transferring. Alright? So what happens is this Chandrayaan starts to revolve around the earth. When it goes away from the earth, it moves slowly, and when it comes towards it, moves fast. Slow and fast. Slow and fast. Slow and fast, like this. You see? So it has to cross these different orbits. When to start a new orbit will be decided by the ISRO. Okay, by us. When to move from one orbit to the other. First orbit is this one, and then it moves on to the second one. Maybe a day or two it might take, okay? I don't know the exact timing. And then again to the other orbit, and then again to the other orbit, and then again to the other orbit. So this is, what happens is, because of the gravitational pull, when it goes away from the earth, the velocity or the speed is slow, right? And when it comes towards the earth, the velocity is high. And because of that, it can slingshot, we call it slingshot effect. It moves like this and like this. It moves like this and like this. And then there will be a point where it will keep on increasing its orbit. That's why they want to be there. Presence of huge and deep craters. The scientists believe that these conditions can hold clues of early solar system. We may be able to know something about the early solar system, right? And find crucial insights about the unexplored part of the moon. That part is unexplored so far. So that seems to be very, very important for the whole universe, okay? Okay. So what are the objectives of Chandrayaan? To demonstrate safe and soft landing on the lunar surface. That itself is a marvelous feat, marvelous achievement, right? To be able to land something on the moon about 3 lakh kilometers away softly and gently. That's amazing engineering, just mind-boggling. We cannot do that. It's not easy for us to do, right? We cannot. I mean, we have never been able to, only 4 countries have been able to do that. 3, right? The 4th one. To demonstrate rover roving on the moon. So if we can make a rover, the rover that you have seen with the wheels, right? If we can make something move on the land of the moon, that's also an amazing thing, right? To conduct in situ scientific experiments. So there are many things that are attached with the lander. There are many, experimental setups that the rover, the lander is carrying. So it can do a lot of experiments, right? Find the mineral compositions, what are the different minerals that are present there, what is the temperature, and what the movement of the surface of the moon. All of these things can be studied and can be sent here so that we know a lot about moon. And it can also measure the temperature of the moon surface near polar region, right? That can also be very, very important for our future. Moonquakes, like we say earthquakes, there can be moonquakes also. Quakes means shaking of the moon, surface of the moon. So to study that around landing site and delineate the structure of the lunar crust and mantle. So to find out the difference between the mantle of the moon and the crust of the moon, and understand how the dynamics of the moon, how it's affecting various different movements on the space, and so on. So these are various different objectives of the whole mission. And it's crucial, it's extremely crucial that it becomes successful. So let's wish all the scientists, all the people working behind Chandrayaan, because it's for the humanity, right? Because it gives us something new. So let's wish them all the best. Thank you. Let's give them a round. That's all.